Welcome to our journey through the cosmos. Today we're diving deep into the giant of our solar system, Jupiter. This gas giant, a behemoth of swirling clouds and raging storms, holds countless mysteries and wonders. Let's explore why this massive planet is so fascinating and important, not just for understanding our own solar system, but for unraveling the secrets of planetary systems across the universe. So, just how big is Jupiter? Imagine this. If our Earth were a nickel, Jupiter would be about the size of a basketball. This comparison helps us grasp the sheer enormity of the gas giant. Jupiter's size is so immense that it could fit over 1,300 Earths inside it. Just think about that for a moment. If Earth were a tiny marble, Jupiter would be a colossal beach ball. That's a diameter of roughly 87,000 miles. To put that into perspective, if you were to travel around Jupiter's equator, you'd cover a distance equivalent to circling Earth more than 10 times. And let's not forget the iconic Great Red Spot, a storm so large that it could swallow Earth whole. And it's not just big, it's heavy. Jupiter's mass is a staggering 1.898 x 10 circumflex 27 kilograms. That's a number so large it's almost incomprehensible. Jupiter packs more than twice the mass of all the other planets in our solar system combined. Imagine gathering every planet from tiny Mercury to massive Saturn and then doubling that mass. That's Jupiter for you. That's over 300 times the mass of Earth. This immense mass gives Jupiter a powerful gravitational pull, influencing not just its moons but also the entire solar system. It's like the heavyweight champion of our cosmic neighborhood. Now, Jupiter is a busy place, with a bustling family of over 79 known moons. These moons range from tiny, irregularly shaped rocks to massive bodies like Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. But a day on Jupiter wouldn't be much fun, lasting a mere 10 hours. This rapid rotation is the fastest of all the solar system's planets, causing Jupiter to have an oblate shape, meaning it's slightly flattened at the poles and bulging at the equator. However, a year on Jupiter, the time it takes to orbit the Sun, is a lengthy 12 Earth years. This means that if you were born on Jupiter, you'd celebrate your first birthday after 12 Earth years. And if you're thinking of planning a trip, you're in for a long haul. The distance between Earth and Jupiter varies, but on average it's about 484 million miles. That's over 5 times the distance from Earth to the Sun. Jupiter sits at an average distance of 484 million miles from the Sun, over 5 times farther than Earth. This vast distance means that light from the Sun takes over 43 minutes to reach Jupiter. So whether it's the planet's colossal size, its immense mass, or its bustling moon system, Jupiter truly stands out as a giant among giants in our solar system. It's a world of superlatives, a testament to the incredible diversity and scale of the cosmos. Now, Jupiter is a gas giant, which means it doesn't have a solid surface like Earth. Instead, it is composed mostly of hydrogen and helium, the two lightest and most abundant elements in the universe. This makes Jupiter more similar to a star than to a terrestrial planet like our own. The planet's immense size and mass create a gravitational pull so strong that it has a profound effect on the entire solar system. Its outer layers are a swirling mix of hydrogen and helium gas, much like the Sun. These clouds form beautiful bands and spots, including the famous Great Red Spot, a gigantic storm that has been raging for centuries. The upper atmosphere is a dynamic and turbulent place, with winds reaching speeds of up to 400 miles per hour. These winds create the distinctive stripes and swirls that we see when we look at images of Jupiter. But as we dive deeper, the pressure increases, squeezing the hydrogen gas into a liquid metallic state. This transition occurs because the immense pressure forces the hydrogen atoms so close together that their electrons break free, allowing the hydrogen to conduct electricity like a metal. This layer of metallic hydrogen is thought to be thousands of miles thick and plays a crucial role in generating Jupiter's magnetic field. Imagine a giant ocean of metallic hydrogen, conducting electricity and generating a powerful magnetic field. This magnetic field is the strongest of any planet in the solar system, about 20,000 times stronger than Earth's. It creates intense radiation belts that can be hazardous to spacecraft and contributes to the stunning auroras observed at Jupiter's poles. These auroras are much more powerful than those on Earth and are caused by the interaction of the magnetic field with particles from the Sun. And at the very heart of Jupiter, scientists believe there might be a solid core. This core is thought to be composed of heavier elements such as rock and metal, and could be surrounded by a layer of ice. The existence of this core is still a topic of research and debate, but it is believed to play a key role in the planet's formation and evolution. This core, likely made of rock and ice, could be several times the mass of Earth, crushed under unimaginable pressure. The pressure at the core is estimated to be around 45 million times the atmospheric pressure at Earth's surface. Understanding the composition and structure of Jupiter's core can provide valuable insights into the processes that shaped not only Jupiter but also the other gas giants in our solar system and beyond. Now let's talk about the most recognizable feature of Jupiter, the Great Red Spot. This isn't just any storm, folks. This is a high-pressure storm, a swirling vortex of clouds larger than the Earth itself. It's been raging for at least 400 years, and its winds whip around at speeds of over 400 miles per hour. Imagine a hurricane that could swallow our entire planet. Scientists are still trying to understand what fuels this monstrous storm and why it has persisted for so long. When you look at Jupiter, you'll notice distinct bands of color. These bands, called zones and belts, are created by powerful jet streams in Jupiter's atmosphere. The lighter zones are regions of rising gas, while the darker belts are areas of sinking gas. These jet streams, driven by Jupiter's internal heat and rapid rotation, race around the planet at speeds of over 300 miles per hour, creating the stunning stripes we see. Now, Jupiter's magnetic field is nothing short of colossal. It's the largest and most powerful magnetic field of any planet in our solar system, stretching millions of miles into space. To put it in perspective, Jupiter's magnetic field is about 20,000 times stronger than Earth's. This magnetic field acts like a giant shield, deflecting solar wind and trapping charged particles from the sun. This trapped radiation creates intense auroras around Jupiter's poles. Light shows far more spectacular than anything we see on Earth. Let's not forget about Jupiter's entourage, particularly its 4 largest moons, discovered by Galileo Galilei in the 17th century. These moons, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. Each of these celestial bodies is a world of wonders in its own right, offering a glimpse into the diverse and dynamic nature of our solar system. Io, the closest to Jupiter, is a volcanic world, spewing lava from hundreds of volcanoes. Its surface is dotted with active lava lakes and towering volcanic plumes that can reach up to 300 miles high. The intense gravitational pull from Jupiter creates immense tidal forces that heat Io's interior, driving its volcanic activity. This makes Io the most geologically active body in our solar system, a place where the landscape is constantly being reshaped by volcanic eruptions. Europa, covered in a smooth, icy shell, is believed to harbor a vast ocean of liquid water beneath its surface, potentially containing more water than all the oceans on Earth combined. The ice crust is crisscrossed with cracks and ridges, suggesting that the ice is constantly being broken and reformed. This subsurface ocean could be kept warm by hydrothermal vents on the ocean floor, similar to those found on Earth, raising the tantalizing possibility that Europa could harbor life. Scientists are eager to explore this icy moon further, as it represents one of the most promising places to find extraterrestrial life in our solar system. Ganymede, the largest moon in our solar system, is even bigger than the planet Mercury, and has its own magnetic field. This magnetic field is unique among moons and suggests that Ganymede has a partially liquid iron or iron sulfide core. Its surface is a mix of 2 types of terrain, highly cratered dark regions and somewhat younger but still ancient lighter regions marked with an extensive array of grooves and ridges. These features indicate a complex geological history, possibly involving tectonic processes. Ganymede's magnetic field also interacts with Jupiter's magnetosphere, creating auroras near its poles. And then there's Callisto, the most heavily cratered object in our solar system, a testament to its ancient surface. Unlike the other Galilean moons, Callisto shows little evidence of geological activity, suggesting that its surface has remained largely unchanged for billions of years. This ancient landscape is a record of the early solar system, with impact craters that date back to the time when the planets were still forming. Callisto's lack of geological activity makes it a fascinating subject for scientists studying the history and evolution of our solar system. These 4 moons are like mini solar systems in their own right, each with its own unique story to tell. From the volcanic fury of Io to the icy mysteries of Europa, the magnetic marvels of Ganymede, and the ancient craters of Callisto, the Galilean moons offer a rich tapestry of scientific discovery. They remind us that even within our own solar system, there are worlds waiting to be explored, each with its own secrets and wonders. As we continue to study these moons, we gain not only a deeper understanding of Jupiter and its satellites, but also insights into the processes that shape planetary bodies throughout the universe. Thanks for joining us on this cosmic journey. If you enjoyed learning about Jupiter, don't forget to like, subscribe, and hit the bell icon for more fascinating space content. From its swirling storms to its intriguing moons, Jupiter reminds us of the vastness and wonder of our universe. Until next time, keep looking up.